Day 19 notes, Algebra 2. On Friday, we discussed after the quiz some simple foiling patterns that start to arrive when we multiply different pairs of binomials. And we started off by discussing what happens when you square a binomial. Remember that when you square a binomial, that means that you start with a binomial, a plus b or a minus b, and then square it or raise it to a second power. One of the first things that we discussed was that a plus b squared is not equal to a squared plus b squared. We cannot simply distribute this power of 2 into each piece within that binomial. And the reason for that is because when the quantity of a plus b is squared, that really means that we need to multiply a plus b times itself. When we multiply that together, we must use the FOIL method, and the FOIL result does not give us a squared plus b squared. You'll remember that it actually produces a squared plus 2ab plus b squared. And it's this pattern here, that we're going to look for in the next few examples. Don't forget, however, that in addition to a plus b squared, we can find binomials squared that were subtraction problems. So a minus b squared, again, will not equal a squared minus b squared. This statement is not true. But a minus b squared, when FOILed, will produce the similar result as above, except this time we'll have to subtract 2ab. The positive b squared at the end still remains positive. So be sure that you're well aware of these two patterns here. Let's look at a couple examples. So we'll label this section Part B. And the first problem that I'd like to look at in Part B is this number right here. I would like to see the quantity of x plus 3 squared. Now remember, when I square a binomial, that means that the binomial has to multiply by itself. X plus 3 times x plus 3. From here, we can continue our foiling process. For the first product, we're left with an x squared. For the second product, the outside two products, we get an 3x. For the third product, the inside multiplication, we have a 3x. And for the last product, the last multiplication, we get a 9. From here, you should immediately recognize that these two are like terms, so they should combine together. And when we do, we're left with x squared plus 6x plus 9. Now, as a side note, we're going to investigate whether or not this answer follows the pattern that we established in the steps above. What we're looking for is the first number of our binomial must be squared in our result. And we get that here. The first number in our binomial is squared in our result. The second number of our binomial should also be squared and written towards the end of our result. We get that here. Lastly, the middle term of our result must be 2 times the product of A and B. 2 times the product of the two pieces that made up our original binomial. And we have that here. I know that we have that because our first number was x and our second number was 3 in the binomial. X times 3 equals 3x, And knowing that to follow the pattern, that result must be doubled, let's multiply that by 2, and we get 6x, which is exactly the center term that I had below. So here's a solution to x plus 3 squared, and it does follow the pattern of a perfect square trinomial. We'll pick up a couple examples in the next video.